As Jane said, my name is Kenny Blum, and I'm Executive Director of the Center for Brain Science, and I'm also involved in something called the Harvard Brain Science Initiative, which is one of the 3 co-sponsors of this event. I really want to start by thanking the 3 co-sponsors for these imaginative programs. This is the 3rd and final in a series that we hope will continue in the future. So first, I'd like to thank Jane, who is, as she said, Executive Director of the Harvard Museums of Science and Culture. I was introduced to those museums when I was 10 years old, and I came here from Chicago for other reasons, but I visited the glass flower collection, and it made a huge impression on me at that age, and I've been a fan of the museums ever since then. I'd also like to thank Diana Munn, who is somewhere here behind the scenes, who is Director of Public Programming and has been running much of the operations of these events. Another co-sponsor for these events has been the Harvard Art Museums. And the key mover for this series has been Francesca Baver, who is the research curator for conservation and technical study programs at the Harvard Art Museums. And finally, and at least from my perspective, most importantly, I'd like to thank Dana Edelman, who has been the galvanizing force behind these imaginative programs and pairings of various scientists and non-scientists in discussions that have been wide-ranging and very inspirational. So I'm going to tell you a little bit about what's going to happen here. First, I'm going to make some other introductory remarks, and then we're going to have sort of formal presentations from our 2 speakers. And then the 3 of us will sit here and we'll have a conversation. And then the final segment will be opening to questions from the audience. And so I would like, even before we begin, to thank the speakers themselves who are doing this on top of all the other myriad things that they do as part of their academic lives. And they're doing it, I think, partly out of curiosity. Maybe they haven't done this sort of thing before. Nobody has really done this sort of thing before. And they want to see what it's like. And I think that our way of thanking them is by asking them interesting questions. So I'll try to do some of that. And even though the questions from you come in the latter part of the program, jot something down. If you have a question during one of their presentations, scribble a note, or maybe, dare I say it, punch away in your phones or something like that, and ask the question at the end, please. So our 2 speakers today, we're very fortunate to have them both young faculty members at Harvard. First, we will hear from Dragana Rogelio, who is an assistant professor of neurobiology at Harvard Medical School. Dragana grew up in Belgrade and came to the States to finish her college degree at Rutgers. And she majored in biology at Rutgers and decided to stay there for her graduate work. She got a PhD in biology and developmental biology with someone named Kenneth Irvine. And she switched, doing her postdoctoral work at Rockefeller University, to studies of circadian rhythms and sleep in fruit flies. Now, you might not think that fruit flies sleep, but I assure you they do, or at least everything that we measure about them is akin to what we would call sleep. And she did some very influential work on molecular mechanisms underlying sleep in these flies, and she got a job at Harvard Medical School as a result. Our second speaker, our other speaker today, is Holi Samuelson. Holi started out, if I read the record correctly, studied biology for a year or 2 at Allegheny College, and switched to studying architecture at Carnegie Mellon, where she graduated as a top student. Came here to Harvard, where she got her master's and doctorate degrees in sustainable design at the Graduate School of Design. And after that, she actually was a professional architect for 7 or 8 years. She applied what she had studied, and after 7 or 8 years, she got a teaching position or chose to take a teaching position back here at Harvard in the Graduate School of Design, and as of a couple of years ago has been an assistant professor there in the Graduate School of Design. Okay, so how do we knit these two pieces together? If the topic is light and health, we'll see what we come up with by the end of this, but here's maybe one way to think of it as a kind of starting point. In the center of our sun, there are fusion reactions. Hydrogen is fused into helium, and that produces photons. It produces particles of light at tens of millions of degrees. Those photons get absorbed by other atoms nearby and get re-emitted as photons in random directions. And so they sort of do a random walk of this absorption and re-emission that takes tens or hundreds of thousands of years, actually, for that photon to make its way through this, nearly 500,000 mile radius sun. Eventually, they make their way to the surface, which is at about 6,000 degrees or something like that, and they're emitted as photons again, but in the visible spectrum. And it takes maybe 8.5 minutes for them to wing their way towards Earth. And the Earth, as you know, spins on its axis at once every 24 hours or so. And so all of life for the past 3-4 billion years, but in particular for the past 2 to 3 billion years, have been influenced in their evolution by this 24-hour cycle of light and dark, except for certain times of the year at extreme latitudes, because the spin axis of the Earth is tilted slightly to the plane in which it goes around the sun. So this has been a fact of evolution for nearly the entire time of life, and certainly all multicelled creatures on Earth seem to have biochemistry that is locked to this rhythm. It's true also for some bacteria. I think we don't really know about some of the other earlier forms of life, but that's been the way it's been for all of evolution. Until, perhaps, it comes to clever apes that we are, and some thousands of years ago, we stumbled upon or figured out ways to illuminate interior and exterior spaces of our lives, and thereby have altered our behavior. So first we burned things. We burned wood. We figured out ways to extract oils from plants and animals, and we burned that. We burned gases. We figured out how to extract and purify oils from coal and from petroleum. We burned that. We burned mercury vapor, sodium vapor. We developed the incandescent light bulb in the 1870s and an electric grid that could power this throughout the world. More recently, we've developed these compact fluorescent bulbs and the LED bulbs that many of you know about. And so we can do this ever more efficiently, and we have light throughout our lives. We have light while we're at work, and we have light while we're at play. And I think now we will hear from first Dragana about the basic biology of circadian rhythms and sleep, and afterwards about how humans have designed their spaces to try to somehow account for that experience of light and dark. So, Dragana.
Okay, can everyone hear me? All right, this is great because I think I can skip about half of my talk after this. Kenny gave a lot of my introduction, but that's okay. So as he said, well, first of all, I want to thank you for inviting me here. Thank the organizers. This is a really fun experiment, I guess, and it makes me feel better that nobody knows exactly how this should go. So we'll all learn as we go along. So it makes me feel less bad that I don't actually know what's going to happen next. So we live on this planet that spins around its axis as it's orbiting the sun. And as a consequence of that, one of the basic facts of life on Earth is that we, at least animals that are living on the surface of the planet, are exposed to light-dark cycles every day. So here we see a picture of the Earth, and the side facing the sun would be lit up, and the side facing away would be in the dark, or at least this is how it should be. If we look at the picture of Earth in reality, though, what it looks like during the night, this is what it really looks like. So this is a Google image of Earth as seen from space during the night. And I think this image is really stunning. It's stunningly beautiful, but it's also stunning to see just how lit up our planet is during the time that it should actually be dark, and that it has been dark through almost all of our evolutionary history. So you can really easily make here what the continent we're looking at. There's this really cute story that I don't know if it's true or not, but it's a good story, where in 1994, police in Los Angeles started getting these reports of people seeing a strange white cloud in the sky. It turns out LA had just suffered a major earthquake, and as a result of this, there were citywide blackouts. So many people in that city, for the first time in their life, had a good view of the night sky, or at least first time in many years. And it turns out this weird thing that they were seeing was not a volcano erupting, it was not a trail from an alien spaceship, but it was actually part of the view of our own galaxy, the Milky Way. This maybe seems hard to believe. It seems a little far-fetched until I show you this next picture. So this is a picture that this guy, Todd Carlson, thank you, Todd, from Canada, took of his house. A fairly typical looking house. You see the sky. You can even make out some stars. And I would say that most of us living in urban or semi-urban places see exactly something like this when we look at the night sky. Then in 2003, there was a blackout that affected large parts of Eastern America, Canada, and the United States, and some parts of the Midwest. And so Todd Carlson lost his power, and he was smart enough to take a picture of his house during the blackout. And this is really a striking image. Even though there are some lights still in his house that are probably from candles and some small portable lights, it's nothing like this. And look at this view. You see a strange white cloud in the sky, and you see all these stars. So this is not a lecture in astronomy. I'm not here really to lament the loss of this amazing view. I do think that there are few things that are more magnificent than an unobstructed view of the night sky. So yes, I feel sad about that, but I want to, most importantly, to think about what this is possibly doing to us. If we're making so much light that we are obscuring the light that's coming from all of these stars, can we think about what this is doing to our biology? So in our bodies, all throughout your bodies, in all of your organs, you have internal clocks, biological clocks that are called the circadian clocks. And circadian means about a day. So these clocks tick with a periodicity of about 24 hours. And they have evolved because through almost all of our history, we did not have alarm clocks. We did not have any clocks of any kind. We did not have anything to tell us what time of day it is other than the sun and the stars. So we evolved this ability to use the information from the natural luminance to inform our bodies as to what time of day it is. Because for many animals, there's a preferred time of day when we should be active, when we should look for mates, when we should avoid predators or act as predators ourselves. So the clocks exist throughout your body, but the main clock exists in your brain. So how do you keep this clock? So this clock that's in a small part of your brain that's called the suprachiasmatic nucleus, or the SCN, is a master clock that orchestrates the function of all of these other clocks throughout your bodies. It keeps them in sync. So how does this clock get in sync with the natural light-dark cycle? Well, the information from a light source, such as the sun or any kind of artificial light, goes into your eye, and then from there travels to the clock in your brain, and it forms the clock. So the light information is directly taken up to the brain, basically, as information about the time of day. And so in your eyes, you, of course, have cells that help you look at the world around you, decipher visual imagery, but you also have cells that are not part of visual forming pathway, but whose primary role is to capture light information, take it to the brain, inform the brain about the levels of luminance. And so there are obvious outputs of the clock that you can immediately think of, such as the control of wake and sleep cycles, but there are also many other things that are not immediately obvious, but that are controlled by the clock, such as many metabolic and physiological functions. So for instance, the production of many hormones in your body fluctuates throughout the day because it is directly influenced by the clock. And so how can you tell that you have this clock? So if I closed you in a dark room where you would not have any access to any external source of light or information about the time of day, you would then rely on your clock, which was previously entrained to outside light-dark cycles, and the clock would guide you through. So you would still retain rhythmic patterns of sleep and activity, at least for a little while. Eventually, you would start drifting. But for a while, your behavior would still be rhythmic because your clock was entrained to outside light-dark cycles. Well, this is not an experiment that many of us are really willing to do. But there is an experiment that most of us have actually participated in, which is traveling across time zones. And so I really like this quote that says, when you travel from America to Europe, your soul takes about 3 days longer to get there. And so, of course, what this is referring to is jet lag. So if you have traveled from here to Europe, you know that you get to the new place, but for several days you really have trouble sleeping. You feel out of sync with other people that are there. And this is because your clock is still ticking on that old time. And of course, if you think about it, there was no really evolutionary pressure to make the clock quickly adjustable to the new time zone, because whoever was able to hop from one continent to the next in a matter of hours, right? Which we can do today. So the circumstances under which we are living today are vastly different from what our ancestors were experiencing. So what is the clock that I'm referring to? So the details here are not important. Don't worry, I'm not going to take you through all of this. But what I want to tell you is that the clock really consists of many different molecules, proteins, the components of this clock, which are actually remarkably similar in the fruit fly, the organism that my lab is studying, and mammals such as mice or us. And really the cogs of the clock and the way that the clock ticks were first found and described in the fly, and were then found to be remarkably similar in the mammal. Okay, but the really important point about the clock is that some of these components of the clock, they go up and down. Their levels change throughout the day because some of them are directly degraded by light. So you can imagine that if you have some of these components high at certain times of day and low at other times of day, you can make a molecular oscillator. And then the output, or what the clock is able to do, will change dramatically from day to night. So that is how a lot of your biology is affected by the clock. Like I said, many things that you're not even aware of, but they are dramatically affected by the clock. So, okay, light. It's the year of the light. We love light, but there are some things to be careful about. If we sort of misuse light, there are bad consequences. You have probably heard people telling you, try to minimize your light exposure in the evening. This is not really good for your sleep, et cetera. And perhaps you've wondered if this is true, and if so, why is it the case? And so I'm here to tell you that unfortunately this is the case. I believe that it is the case, that we are subjecting ourselves to levels of light that are not good for our circadian clock and for our overall biology. So it's good to be outside during the day for at least 30 to 60 minutes during the time that the sun is bright. This is not what your dermatologist will tell you, but for the clock, it's good to be outside. So if you're in the sun, of course, the sunlight consists of different wavelengths of light, but it's the blue wavelength of light that is really good for your clock. It also elevates your mood, it promotes your attention and your alertness. If you are, on the other hand, and perhaps we'll hear more from Holi about what levels of luminance are actually found in different environments that we're in. If you are, on the other hand, exposed to blue light at night, this is bad because your eye doesn't really know that the light that you're exposed to is not the natural light from the sun and that it's not actually day. And you're fooling your clock into thinking that it is still day. And unfortunately, many of the electronic devices that we're so tied to today, such as our iPads, our computer screens, and even LED lights, are very rich in blue light, specifically in blue light. So blue light suppresses, during the day, it suppresses production of melatonin, the hormone that helps you go to sleep, but it also has antioxidant and anti-cancer properties. But if you are exposed to that same level at night, you are still suppressing production of melatonin, which then affects your sleep and wake patterns. Okay? So it's known, for instance, that that night shift workers, which are constantly under these sort of strange light and dark schedules, have increased rates of for instance, breast and colorectal cancers, and their survival rates are actually decreased. Their prognosis is worse. So what can you do about this? Well, I realized that when I was making this talk that I know this stuff, I say this stuff, but I'm just as bad as anybody else. I love my iPad. I love reading it at night and so on. So actually, a few days ago, I ordered a pair of glasses that are supposed to block at least part of the blue light coming from the screen. And so this experiment just started 2 nights ago, so I can't report yet if it actually works or not. They actually look pretty cool, so but at least that. I have them in my bag. I can show them afterwards. There are some programs that you can download that will help you filter out some of the blue light on your screens, and you can actually, I would recommend changing the setting of your screen to less bright. So these are kind of practical things that you can do. And I'll just say that in terms of melatonin production, even 50 lux of light has been shown to suppress melatonin production. And if you go outside on a really bright day, you can have about 100,000 lux of light. And indoors, it can be from like 100 to 2,000 on average lux of light. So even a small amount of light can suppress melatonin production. Okay, and finally, I have to tell you, well, this is good news or bad news, depending on how you look at it. So I want to tell you that flies are just like us, or that you are just like flies. So this may not be, you may not be so happy to hear this if you don't think that these creatures are cute, which I do think, I do think that they are. But the good news about this is that we can then use them as a model system in which we can study circadian and sleep biology. We can do experiments that we cannot do in us. Okay? So Brian Song, a PhD student in my lab, is studying exactly this. He is studying how light coming into the eye of the fly affects sleep and circadian rhythms of this animal. So we and others have shown, this has been known for a long time, that if you subject these animals to aberrant light cycles, that their sleep is really disrupted, they have abnormal rhythms. But Brian has shown, for instance, that if he tricks these cells in the eye into thinking that they're seeing light, even when they're not, he activates the cells artificially into thinking that they're seeing light, the fly really has trouble falling asleep. It takes it extra couple of hours to wind down and go to sleep. So now we can use this animal as a model system to understand the basic biology of sleep regulation. And I think this is all the time that I have for now. I have some extra slides with data, but I don't think I have time to talk about it, and I can tell you later a little bit about the kinds of animals that we're looking at in my lab. But I just want to leave you with this thought. Think about the evolutionary history of our species and of all other life on our planet. The conditions under which we lived for hundreds of millions of years, several billion years of evolution were so different than what we're living in today, the last century, and particularly the last decade or so. So how many of us have reached in the middle of the night for our cell phones to check our email since we're already up, right? I've done it many times, for sure. But every time you do that, you are actually affecting your biological clock. So evolution just has not had time to catch up with the insane pace of development, of technological development, technological advances that we are experiencing today. Okay, thank you. I guess the questions we'll take afterwards. Okay, thank you.
Thank you, Dragana, and thank you, Kenny. Well, we spend 90% of our time indoors. And if you think about it, some building occupants can never go outside, whether it's hospital patients, the elderly, prisoners, AKA all of us in New England winters. So what is it like inside? Dragana mentioned some of those lux levels that affect hormone production. Well, inside in direct light, I measured in my house earlier this week, 15,000 lux in direct daylight. So is that part of good design, just maximizing that daylight during the day and minimizing the exposure at night? And avoiding midnight trips to the refrigerator. With the proliferation of all-glass buildings from Boston to Bombay, some architects might think that this is the case. And we do know that studies have correlated good daylighting in buildings to a number of outcomes: reduced length of hospital stays, longer sleep duration, reduced employee absenteeism, increased retail sales, improved classroom performance. And I won't get into that too much here. We can talk about it later if you're interested. And furthermore, some research actually suggests that the outcomes of these financial benefits of these situations far outstrip the construction costs of good daylighting. But there is more to good daylighting than more is better. And why am I talking about daylighting rather than just lighting? Well, I think that instinctively we all know that there's a difference between electric light and natural light. I think part of it has to do with the brightness levels. Part of it has to do with our connection to nature, whether it's from the view itself or from the passage of time that we experience with the changing light levels. And part of it also has to do with the wavelength of the light. Now, Dragana mentioned the importance of blue light to our natural systems, and you can see that indoors, we're not really getting that blue light from our lamps, other than the so-called full spectrum lamps, or now the cool white LEDs. So should we all run out and buy the cool white LEDs? Well, apparently that's not what we need in the evening, but a lot of people prefer the warmer light, including myself, and I'm not sure if it's hearkening back to the caveman fireside, our fireside heritage or what. But some of us are drawn to the more reddish light. So it's not just the brightness levels, it's not just the wavelength, and it's not just more is better. So I'd like to talk about some of the things that architects consider in terms of good daylighting through two case studies. So the first one, this is Gund Hall. It's the Graduate School of Design building. It's just on the other side of Sanders Theater. And Dragana mentioned that, keep in mind, outside you can get about 100,000 lux on a very clear day in the summer, closer to the equator, and overcast maybe 15,000 lux. Well, what happens when you walk into a building? Well, here this is our lobby, and I measured 30 lux in this space. The eye, now correct me if I'm wrong, you're from the medical school, I think the eye can adjust to about 12 orders of magnitude of light. And the iris itself can adjust to about 2 orders of magnitude, is that correct? And then other than that, it needs time to adjust. So architects need to think about that. If you've ever walked in late to a matinee movie, you know all about this as you sit on the person next to you. So one thing we can do is to try to make brighter transition spaces, but we don't want them so bright that our destination space seems dull, because we're always thinking about light in terms of its relative contrast. So here, the idea is that you're supposed to look at the exhibits. So those are brighter. So the lobby itself is a bit dim, perhaps a little bit too dim. But that's something to think about. Sometimes borrowed light by having destination spaces like offices that have glass on the outside so that the corridor feels a little bit brighter, but not so bright that you turn on the lights unnecessarily when you get to your office. Now here's a typical office in Gund Hall. You can see that we only have 140 lux here without the electric lights on, or 450 lux with the lights on. Typical levels in an office are about 300 lux, maybe 500 lux. So this is pretty dim, considering that the desk is so close to the window. So what's going on here? Well, I have evidence to believe that this office was designed for vampires. Either that or it was renovated in the 80s. Because there's a very dark film on the window. It's only a 17% light transmittance. So why would anyone do that? Well, after the 1970s oil shock, there was a number of design efforts that were maybe overzealous in terms of saving energy, and one of them was putting dark film on windows. So here you can see reflective glass. And what's happening is the idea is to block the heat, the long wave radiation. And the only way to do that with that kind of technology at the time was to block both the short wave and the long wave radiation. Thankfully, we've progressed in terms of glass technology, and now we have low emissivity glass, et cetera, that can spectrally select the radiation. So we can let in more light and less heat. So this is good news. However, I'm not even sure why anyone was blocking so much heat or light in that north-facing office. Here's a model of Gund Hall, and you can see here's the office. And I'm not going to get into this too much, but this is showing us the path of the sun throughout the year. And so one thing we can see, if I were to keep the labels on here, is that this window is only experiencing direct light in the very early morning and late evening hours in the summer. So I'm not sure why I ever needed a 17% light transmittance on that window to start with. So this is something that good architects should consider when they're designing buildings, and that you should think about even in your own houses. Also, how's the context affecting the light? If this window were on the first floor, it would be in shade most of the time. So here's the main space in Gund Hall, which I really enjoy. These are all the students' desks, which overlook each other in these balconies. And you can see that this is pretty much an all-glass building. This is a giant south-facing glass wall. And what's going on? All of the blinds are closed. That's pretty typical in a shared office space. And you can see that from my vantage point here, I'm still only getting 230 lux with the electric lights on, while we're paying the full energy penalty of this all-glass wall. Because I'll tell you that glass is the worst thermal performer in the building envelope. It's like getting all bundled up, putting on your polar hat, and forgetting your pants. So we try to do as much as we can with as little glass as possible. There's also a problem with the solar radiation through the glass. So what's happening here, if we look at the typical situation, east or west facing glass, so these are the months of the year, and this is how much solar radiation we're getting. This is sort of a fictional 40-degree latitude here with no clouds. So what we might expect is happening, that we get more light, not just light, but overall radiation in the summer. But what we're seeing in the south-facing, the equator-facing glass, that's pretty amazing, is that we get more radiation actually on a south-facing surface in the winter than we do in the summer. And the reason is because if you think about it, that the equator-facing surface is more normal to the light, whereas because you think about how low the path of the sun is in the winter compared to the summer, when it's coming from such a high angle. So that's why south-facing glass can be a good thing. It can be especially a good thing if you have some exterior shading. It can be an even better thing in a building like a house where you have more of a heating load. You don't have so many computers and people making it hot in there. But you can also see what's going on with a horizontal surface. So this is why skylights are a last resort. So in Gund Hall, we are paying that full energy penalty for all of that glass, and the blinds are closed. And it turns out, research has shown that that's not an unusual situation, that people in a shared workspace will get up and close their blinds when they experience glare, because no one wants to not be able to do their work because they're being blinded by the sun. But no one really feels ownership of the blinds to get back up and open them again. So what often happens is they remain closed until the next day when hopefully the custodial staff will open them. Or maybe they stay closed all the time. Or if we're lucky, someone will feel ownership and open them again. So that's something that architects have to consider. And I'll talk about why it might have been a better idea to block that light on the outside rather than inside of the glass anyway. But here I've moved directly below that position. Now I'm on one of the desks that's underneath the balcony. And you can see now we have 450 lux. And we have these electric lights on. So that's unusual that it's actually brighter there, when this is not really so much of a daylit space. Well, the reason is because the ceilings are lower here, and so we sort of need it to be brighter to psychologically overcome the lower ceiling height. Also, our eyes, like I mentioned, we think in relative terms. So now I'm talking about luminance, about the light that's reaching your eye. And we have these bright light sources in the distance in our field of view. So in order for that not to be a glare, we need more light. So it's interesting because some of my students will think, oh, okay, as they're designing a space, if I want to get more light on this desk, then I should make bigger windows or brighter windows out here. And well, that might be technically true. The perception will change. And what you really need to do to make this space appear brighter is to reduce that contrast a bit. This is our cafeteria, and you can see that recently they've added this film to the window, this frit, to try to reduce the light levels a little bit, and they're still pretty high. You can see a before picture before that frit was put on, and you can see this woman who is diligently getting her daily dose of sunshine. My students in my class did a design project to try to design an intervention for this space because there is a bit of a glare problem. So what they did was they used this daylighting metric that has a high and a low metric, high and a low level throughout the year, and they designed various shading to try to intervene in the space. So that was one solution. Here's another solution. And apparently the students were listening in my class and threw my words back at me because one group came and proposed that they would just plant trees outside of the glass. And it turns out that's actually a great solution because any kind of shading that you design that's fixed is going to react to the fact that the sun is symmetrical. So we're going to get the same exact path of the sun on September 21st as we do on March 21st. But if you think about it, your heating and cooling needs are really different on those two different dates. Well, the nice thing about deciduous vegetation is that it responds to the thermal cycle. So it's actually pretty much losing the leaves when we need it to lose the leaves. So it's actually a great shading device. And I've pointed out a number of the problems of Gunthal, but perhaps the most successful lighting strategy is that we have a number of balconies and terraces around the building. So it's very convenient for occupants to just pop out and take a break. And perhaps that's one of the best design features that we can provide for the health of occupants is just the opportunity to conveniently get outside every once in a while. The second project that I'm going to quickly go through is corporate headquarters in rural Virginia for a Fortune 500 company for about 1,000 people. And one of the hardest problems in large buildings is getting light deep into the space. And so you might have seen this solution is becoming more and more popular these days. This is considered a light shelf. So the idea here is to not only block that direct light before it goes through the glass, in which case you get the greenhouse effect. We've all parked in a hot parking lot. You know what happens when the light passes through the glass, re-radiates within the surface of your car, and it can't get back out. So that's why we want to block the radiation before it gets into the building if possible. And also trying to bounce this light deeper into the space. The client had a large site, so we were able to make whatever shape building we wanted. So we purposely made one that was very thin, just so that people would not be sitting too far away from a window. Now, in many countries in Europe, they actually have green and blue laws or right to light laws, which mandate that people cannot sit too far away from a window. And I think that that's a great thing. We also had the opportunity to swivel the building on the site. And ideally, we would have picked something that was pretty close to south for those reasons that I showed you on that graph. So ideally, we wanted to have the long axis facing south and facing north. We had some constraints on site with some wetlands we were avoiding, so we tilted it a bit. And we preferenced facing east, because if you think about it, you want more heat in the morning than in the afternoon. Ideal for this climate, I think, would have been about 7 degrees east of due south, but we got it to about 15 degrees off, which is still a good thing. So in your house, for example, south-facing glass is a really good thing. You can get that, the light that you need. You can do a little simple horizontal shading and block the heat, and it's going to work out well to give you the light at the time of the year when you need it. On this particular project, I think one of the most successful design moves was that the client was willing to pay for structured parking. So rather than cutting down the whole forest and putting in parking lots, paid a lot of money to put structured parking to keep the trees. Incidentally, this was already developed before we got there. So here's what the building looks like, which is that you can't really see it. And here you can see that we treated the different facades differently. So on the east and the west, not that much glass. There's a lot of glass on the north. And if you were paying attention earlier, you know this was an energy penalty. But this was done for the view of the trees. And here you can see those light shelves. You can see in the stairs we have these roof monitors trying to get something that's more like a vertical glass rather than a horizontal glass. And here is a view of the floor plate. And one of the things that we did, which was unusual, was we started off on day one with an interior designer. And the first thing that they did was go shopping with the client and pick out the system's furniture, the cubicles. And the reason we did that, which usually would come years later in the project, was so that we could actually make the width of the building to be no wider than it needed to be for corridors and that system's furniture. So it's 88 feet wide so that people could be as close to the glass as possible. And now it's kind of common practice to do this, where everyone in cubicles has views. We've made the offices perpendicular rather than parallel to the glass, and they have their own windows so they can see out. Here's a detail showing the facade. And if you're going to go through all that trouble to daylight buildings, then even if it's your own house, using light-colored interior finishes helps to also bounce the light deeper into the space. And using dimmable light, low partitions, and glass on the top all helps to support that daylighting strategy. So the motivation of this company was to provide a comfortable and hopefully healthy workplace for their employees, especially since there are multiple corporate headquarters in the area, and they wanted to attract that limited pool of talent. And I think the successes of this project really are the view, and the ability to rest your eyes when you're working there and to look at something distant, and then also to have that connection to nature. It does really feel like you're working in a treehouse in this building. Thank you very much.
Fantastic. That was really fascinating, both of the talks. I thought maybe a thing that struck me as you both were talking was that I wasn't sure what the health concerns are. I don't know if we know this, but from the basic biology point of view, is it really sleep problems that are the root of the health problems when you tinker with lighting? Is that, or might it be something else?
Well, if you say, is it just sleep problems? I mean, having sleep problems is never just having sleep problems, right? Because if you don't sleep well, there are lots of consequences of that are, this is really bad for your health. But I think it's not just that. It's not just the amount of sleep that you're getting. It's the being really in sync with the natural light-dark cycles is optimal for your health. So as I said, people that do night shift work, even if they sleep enough hours during the day, it's not the same as being exposed to natural light during the day and not so much of it at night. So everything in that case, if you're exposed to abnormal light levels, is really out of whack with how you're wired, how your biology is hardwired and set up to be. So, like I said, melatonin, for instance, it's been shown to have other functions other than just putting you to sleep. So it has anti-cancer and antioxidant properties and so on. And this is just on the surface. It's really obvious that this is going on, but there are lots of things that we still don't understand. And I suspect that it can only get worse, right? Like in the sense of we'll uncover more things that are going wrong in this case. So I doubt that anybody's going to say that everything's fine.
So at least at one level, a kind of partial summary of one thing that you both touched on is that we have too little light during our working day inside, and too much light or blue light or something like that these days at night. And maybe that they're also not synced with the circadian clock. Of course, when we're at these latitudes, the duty cycle of light and dark also shifts, and I don't know if there's something optimal. I mean, should we all be at the equator? Do we all want 12 hours of light, and or does that matter? I mean, it seems awfully short to have 10-hour days, 9-hour days, or something like that. But I don't know if that's just quantity of total daylight or something else.
Well, some of the studies show that the seasonal affective disorder, you can speak to this probably better than I can, but something like 9% of Florida population has it, and something like 30% of Nashville and New Hampshire has it in the winter months. So I think there is something to
latitude,
the length of the day.
But even on a day in October, November, I mean, you're supposed to be outside for at least half an hour, 60 minutes. Like I said, in bright light, that would be the best during morning or close to noon. So again, we're kind of told to shield ourselves from the sun and to not go outside during really bright hours. But maybe you can wear sunscreen and still go outside and be in relatively bright light. But yeah, most of us spend our days inside. Like you said, we don't spend enough time outside. That's definitely true. And I would say one thing that I would advocate for is getting rid of the daylight savings thing. It's just not great. I mean,
getting rid of daylight savings. So we just got rid of it a week ago.
Well,
and
no,
I don't know
getting
if
rid of the whole concept of shifting your alarm clock. I think it's.
I see.
I think it's dumb and unnecessary. Okay. And I mean, I understand historical reasons, but today I don't think there's really need for that.
Right. Although when it gets dark at 4:30 today, we might prefer the daylight savings time to the.
Well, look, it's going to be either before or after the beginning of. Or
maybe
at
it
the
depends
end of the
whether
day.
you're a morning person or
It's not like you're going to change the actual schedule of it's just, but you're shifting yourself, like you're shifting your clock twice a year, I think, unnecessarily. So I know it's for agricultural reasons and so on, but I really would like to see some data as to how significant that is today. And I think that people that are working on farms will probably work according to their own schedule anyway. And I think for the rest of us, I don't think it's a good idea to.
So are there, I mean, I think that there's some studies but I'm not sure how reliable they are, that suggest that there are morning people and evening people naturally.
That's true. Yeah, that is true.
Yeah.
Some of these defects, or deviations from what we are perceiving to normal, have been mapped to genes that are actually that were actually first found in the fruit flies.
So are there morning flies and evening flies?
There are all kinds of, So we've actually generated, and other people have generated flies with various kinds of mutations that have serious sleep defects, that have trouble falling asleep until much later than when the lights are turned off, or that have trouble staying asleep, or that have very much interrupted sleep throughout the night, or that sleep during the day instead of night, and so on.
So another thing I found myself wondering in each of your talks is, do you think that there are, let's say, technological solutions or improvements on the horizon? Like, imagine, so one of the things that, Holi, when you and I chatted earlier, and you alluded to it briefly here, there's a tension between designing for energy efficiency, which I think is mainly your main line of work, and considerations about light, because current kinds of glass are poor thermal insulators, and they have this greenhouse effect property. is it possible to decouple them? So imagine that you had light collecting devices on the roof that funnel through optical fibers into every cubicle or whatever it is, your house. Daylight, if you could preserve that sort of broad spectrum. And since you said that even on cloudy days, it's many times brighter than it is at your desk or something like that, if you could somehow deliver that light, you'd sort of have the best of both worlds. Or on Dragana, on your side, what do you think about melatonin supplements? So those kinds of things, are there technological approaches that could at least help, or is that maybe moving in the wrong direction?
Or maybe rotating houses.
Yeah,
That would be pretty
well,
cool.
I think first of all, that's why I spent so much time talking about the orientation. I think getting that right can really help on the energy side. But first, let me just back up and talk about, one of our national laboratories did a study of commercial buildings and using today's technologies, and they found pretty much in almost every climate that we have in the US that windows are a net loser. And the bigger the windows are, the more energy you're going to be spending in large buildings. And I did a study where we were looking at multifamily residential, and we were looking at realistic design options. And we did about 120,000 simulations. And the biggest thing that affected energy was the size of the windows. We did this in New York, Beijing, Shenzhen, so different climates. So right now, with the windows that we have now, and the lights that we have now, it's a problem because lights with LEDs, with occupancy sensors, with daylight sensors, they're pretty efficient. But if we're still using double pane windows, they're pretty inefficient. So if we went to triple pane windows, the story would change. If we went to something with a nanogel, which is a kind of great insulator that's also translucent, the story would change. But right now, those things are expensive, and lights are cheap, and lighting technology is cheap. So it's kind of an economic problem right now.
But do we like the daylight? I mean, why do we like the daylight? It seems like it's not just for, how many luxes are at your desk. I mean, you want to be by the window, even if you're looking at trees or whatever. I'm not sure, but you do studies on behavior of building occupants and things like that. I mean, is it that we're so thirsty for light that we'll just move towards daylight and we like it, or is there a way of assessing why it is that we want to be by windows in particular?
I've heard a number of theories, and I'm not sure that we know all the reasons yet, but I think, one of it is this connection to nature and the ability to refocus your eyes by looking at something that's in the distance. And I think refocusing your mind every once in a while to remember that we're part of this natural world. I mean, so I think I can't emphasize enough how important views are. And I think the first time that I taught my energy class at the GSD, I created a bunch of architecture monsters because I think I emphasized the energy part so much that I saw all these studio projects with clear story glass where there were no views, and I realized, I forgot to emphasize how important it is to health and sanity. And I mean, we could look at those studies of what happens to classroom students and office workers when they have views or when they don't. I mean, it's really important. So I think that, despite the energy penalty, we need to have glass. We need to be able to see outside to the views. We don't necessarily need to have glass that goes all the way down to the floor if that's not helping us. That's usually not helping bring daylight into the building. So I think we need to just do more with the glass that we have.
But also maybe the spectrum of light that's coming from the sun is something that we've kind of optimized, not optimized for our health, but we've evolved to sort of optimize our health in response to that kind of light. And when you're, any artificial light that you have is just not recreating probably the full spectrum of light.
And it's interesting too to see what occupants do. If you go into a space like someplace that's open, like maybe a library reading room, where people have their own choice to sit wherever they want. According to a lot of the guidelines that architects have been using for years, there's these certain upper levels of light, and beyond that, it's considered glare. But if you kind of watch what people do, there's a lot of people that will sit right next to the window, right in the direct light. I mean, there's people in my photographs that were doing that, and I tasked my students to walk around with light meters for a week and find spaces that they like and record them and talk about them. And it was interesting because I hadn't proposed to them yet the guidebook of these are the light levels that you should like. And it turned out that I had to completely rethink the way I thought about light levels because the students were over and over again picking these very bright spaces, and they enjoyed them.
One other thing could be the temperature as well, that when you're in sunlight, you're getting light together with a warm sensation. And we know that that can do a lot for your mood. The clock is also sensitive to temperature. I don't think it's really happening on that level so much, but there is probably some perception that's generated, or it's doing something rather to your biology where you're getting the light and the kind of heat at the same time. So that would be my guess. But you're asking also what can be done. For instance, I do think that the electronic devices could be made in a different way that's perhaps emitting less blue light. Why not? So Apple, if you're listening, why not? I mean, that's one possibility. Because I think that, I'm not 100% sure about this, but I think that even the TVs, the old TVs, were producing less of the blue light than the things like tablets are producing today. So there are things like that we could do, and maybe just be mindful also of our lighting inside in the evening. But one thing that you actually mentioned, which I thought was interesting, is this attraction to light that's perhaps warmer. So it's true that the light that you get from a candle or from a fire, it's more in that sort of reddish spectrum, right? So in that case, even the lighting that we were using up until 100 years ago, right, when electricity started being more widespread, even if you had more lighting in the evening, it was of different kind of quality. So I don't know if I would advocate for all of us going back to candles, but that has actually crossed my mind. As I was preparing this, I'm just going to be decided to kind of experiment with different stuff. So actually, I may read by candlelight. It sounds nice.
Actually, they have lamps now that will they can change color, and you can there's an interface you can dial up whatever color you want. And
are they LEDs or are you?
And so they mix to give you whatever color you like. And so one of our doctoral students, Andy Payne, invented this great interface. He was also doing things with thermal, with the heater and the fan and everything in the room, but also the lights that would learn your preferences over time, kind of like a Nest thermostat. And so I was a guinea pig in his experiment, and so I had these great lights in my office, and I would dial them to be blue during the day, and then to become more yellowish red at night, and eventually the system would learn that was my preference and just do it on its own. So, let's just get Andy to make those mainstream, and we can all install those.
Dragana, do you take melatonin for jet lag?
I was not taking melatonin for jet lag. Again, as of 3 days ago, I started taking melatonin in the evening. But I'm not sure that this really, I have done it sometime in the past because I have lots of sleep problems. I don't think that it worked for me so great, but there are people that swear by it, so I decided to try. I think that it's difficult to really optimize the amount that you're taking because this is going kind of directly, you're taking this amount that's perhaps not really close to what your body would be producing, or it's more than what your body would be producing. So I don't know. I'm taking it, last 2-3 days.
Small N experiment.
Yeah.
No controls.
I wish I had no control. Well, I have control of me before, historically, very bad sleeper. So.
Okay, maybe let's shift gears and take questions from the audience.
Okay.
Yes, you were quick.
I'm wondering actually if maybe our attraction to the longer wavelengths might indicate we were at some point in the evolution crepuscular creatures, and so we might be actually attracted to sunrise, sunset colors. That tells us to get out and flourish or whatever it might be. But actually, what I was going to ask is, has anyone done a balancing of health issues in time
I'm not sure. That
I've heard of that problem and that the LED, the new, more efficient streetlights were much brighter and that.
And blue.
Interesting. And so I have heard of them.
Streets before and after, and it goes from yellow to blue.
I have heard of the problems, and I have heard that they've been retrofitting some of the retrofits because they were too bright. But that's interesting. That I don't know if anyone's done a balance.
Probably haven't really been studied, but I know what you mean. I was actually in New York last week, and I was staying in a hotel that was all glass, and I had this great view. But it was on the second floor, and it was and I love New York, and I wanted to keep my shades up, at night. But I literally could read in the room, without turning the lights on in the room. It was just so incredibly bright outside. So in the end, I caved in and I pulled the shades down. So I would imagine that this is something definitely of a problem, right, at night. I mean, if you want to keep your shades up, this would be difficult. But I'm not aware of any studies of driving and so on. It makes sense what you're saying, keeping the drivers alert, but
do we know why? Does anybody know why we switched from mercury to sodium vapor lamps, which went from a bluer color to a yellower color?
I don't know.
Yeah, because of the mercury waste? Is that the, yeah, okay.
Yeah, disposal.
Disposal of the, yeah. So, yes, please.
I'd like to hear more about those glasses. Are those only for research, or is it feasible?
No, let me get them. I'll show you. They're not just for research. No, they are.
But if
can go.
If you're filtering out the blue, and you told us the blue has a lot of power in it, is it much
night.
dimmer?
No, so actually these ones, I got the ones that are, I think these are not maybe the most efficient. So often they look kind of reddish or orange. These just look like regular glasses. Okay, right? So they just, when you look through, maybe if you look at your computer screen, it just has a little bit more of a yellowish orange color to it, but not very much. It's not that different. If you those are available for anybody. You can go on Amazon and buy them. And
What would you call them?
blue light, just type in blue light blocking or filtering glasses, and you'll find them. And they cost anywhere from $10 to $100. And there's a lot of them that are available.
In your research, have you found any light that helps people with seasonal affect? I think it's called seasonal affective.
Seasonal affective disorder. Yeah.
Yeah. So again, this kind of light that promotes mood and alertness. I don't really study this because we study flies, but the same kind of light, again, that's disruptive to you in the evening is actually good if you take it, if you are exposed to it during the day. And I think that it's about 10,000 lux or so of light. And I think that these lamps are more of the shifted to the blue spectrum. And this actually works.
How long do fruit flies, they sleep also for about 7 hours?
They sleep, so in the lab, we keep them in 12-hour light, 12-hour dark conditions. And they sleep for much of the night. I would say on average for about 10 to 12 hours they sleep.
So the things that we see flying around all the time when we have bananas out.
Yes. Those are the fruit flies. Those are what? They do stop moving. They absolutely stop moving. And not only that they stop moving, but they actually are in this state that's very much similar. It's not just immobility, but it's a state of changed perception of the world, so they don't react to the stimuli. So I wouldn't advise this because I like them, but if you really wanted to kill them, if you did it at night, it would probably be easier to do so because they don't respond to stimuli the same way. Actually, I see my postdoc there in the audience, Iris Titos, who's working exactly on this in my lab. So she's studying how flies at night really elevate their arousal threshold, meaning that you need a stronger stimulus to get them to react. So it would be the equivalent of whispering to you something during the day, you respond. If you're asleep, you don't, and flies do the exact same thing. So trying to figure out how.
The
how this is
woman in the
going to
blue shirt with the hat.
Okay.
I have a big question, and I really hope you can answer it because I'm really kind of disgusted the way things are going in our state. And you mentioned the fact that light disrupts your circadian rhythm. And there are some residential areas that not only have bright floodlights in their window that didn't used to be there before, past 10 p.m. And noise, as we all know, because we're an educated audience, noise has even more harmful effects than light, more of them and more serious. And so, because of this, I'm wondering if you know why a private, or I should say, a public in name only company builds this BU New Balance field under a residential building, practically underneath, and
Pardon me.
we don't have either now. We hear all the sound when the lights, when the doors and the windows are closed, and we have this, light, whatever, that's blinding. It's a health hazard. And I was wondering, when the hearing, we discussed that we didn't want this. So why was this allowed to be done? Because it's a very bad effect, as you had mentioned.
Money, probably. Why it's allowed? I mean, probably, some.
So I think we don't have experts on that particular
yeah.
aspect of the topic up here, unfortunately. Somebody else, yes, here.
I was wondering if you could expand on the impact of light on mood. I happen to have lived in Africa off and on for 5 years, and it is really remarkable, the intensity, the difference in the intensity of light, and the change in your mood. Now, granted, you're on this 12-hour darkness and 12-hour light cycle, but you also have light that is reflected many times over, so it's coming at you from many, many different angles.
I see. That's interesting.
And of course, that's where our evolution started.
Right. So, the question was about the mood, the light and mood. So the effect of light on mood, and the lady said that she lived in Africa for a while and she noticed the difference. So you tell me, were you happier was your mood better?
Yeah,
Much happier.
Everybody is,
Okay.
for many reasons, but.
But exactly, so I was going to say, as a scientist, we would call this control. You need to do a lot of controls, right? You would, in that case, you would have to control for a fact, that you're living in perhaps in a brighter environment, but also environment that's socially different, and there are many other things that probably contributed to you being happier living there. But there are pretty definitive effects of light on mood. As I said, as somebody mentioned, the light therapy for seasonal affective disorder is very efficient. So it is the blue light that promotes mood, and I think part of that is actually coming from the fact that you are more aligned with the natural cycle. And as I said, the circadian clock controls production of many different substances in your body. So many of the hormones are fluctuating actually throughout the day. The biology of this is actually quite complex, but it's heavily influenced by light. So there are many things that you're not even aware of, but that are controlled by the clock. There's actually a cute story about a researcher who was working on some protein, and he had somebody come into his lab to take over that project, and he could never see the same results as the student that was working on it before. He could never see this protein. It turned out one of them worked during the day, one of them worked at night, and so you see a lot of the protein at one time of day, and it's completely absent in the other. And so this guy apparently, or so the story goes, switched to studying circadian rhythms. And so there's a lot of biology that's not really immediately visible to us, but it's influenced.
There are also, I think, we don't understand the connections, but there are some links between various kinds of mood disorders and circadian disruptions as well.
Yes, absolutely, yes.
So, again, there may be some underlying biology
there. May be
there.
some, and actually people are studying something like this is my previous lab, Mike Young's lab, my postdoctoral advisor is studying this a little bit.
Maybe we'll take two more questions, and then perhaps our speakers will be good enough to stay for a few minutes afterwards, but 2 more questions and we'll wrap it up. Very far in the back there. Yes. You. Yes.
Are rooms with no windows a good idea from a health? I'm sorry, bedrooms. Bedrooms with no windows. Would that be a good idea from a health or efficiency standpoint, or not?
I would say no. This is a panel on health, but I think that ventilation is also really important. And so well, you can have mechanically ventilated bedrooms, more common in, let's say, a brand new passive house, which is a super, super energy efficient house that's so tight that you need mechanical ventilation to make sure that the air changes enough in there. But that's very unusual. Or, sometimes there's mechanical ventilation in multifamily housing, but we pretty much rely on either the building leaking or someone opening a window to get good ventilation in bedrooms. So, and that's a problem, and that could be another panel that I would love to talk about. We need to not rely on people opening the windows in the winter to get good fresh air. But I would say that, for that reason, as well as perhaps the lighting, I think that windows in occupied rooms are a good thing, especially bedrooms. Bedrooms, yeah.
Yes. Yeah.
We talk a lot about how blue wavelengths affect us in terms of wakefulness, but there's so many wavelengths. There's almost infinite if you were to divide it down. Do we really have any information on how other wavelengths affect us, either psychologically or emotionally?
So I think, as I mentioned, I think that that's part of the appeal of natural sunlight, is that it is a mix of all these different wavelengths. And I would say that we don't really understand on a very deep level what this is. I mean, Holi mentioned that you're kind of instinctively drawn to warmer colors of light. And so even, if it kind of elevates your mood, if it makes you happy, so that's already a function, right, of a light that's a little bit warmer. But I don't think that we have really enough information to say specifically about all these different colors of light, what they're doing to us. But I would guess that probably that mixture of different colors is what makes particularly sunlight important to us, and why you can't really, being inside in a really well kind of lit conditions during the day, conditions that are really designed to mimic day and night. I don't think that we're at the stage yet where we can recapitulate sunlight being outside.